Let's review area of a hexagon. This is a regular hexagon. Regular means that each side is exactly the same length, so all sides are the same. So if it has a perimeter of 42 and there are 6 sides, 42 divided by 6, we now know that each side is 7 centimeters. Now, how can we find the area of this? Well, to find the area of this, we can break it into shapes we know. We can break it into triangles. By breaking it into triangles, we can see there are 6 identical triangles. But to find the area of one triangle, we would need to know the height of that triangle. So I'm not sure how to calculate the height of that triangle, only knowing the base is 7. Well, the neat thing about being a hexagon is you know that these angles are all the same, and there's 6 of them. So there are 6 identical angles going around this circle. And since a whole circle has a 360-degree rotation, we now know that each angle is a 60 degrees. And we also know that these 2 lengths are identical. So if that is 60 and these 2 are the same, and making these 2 angles exactly the same, then this has to be an equilateral triangle. Right? 180 subtract 60 divided by 2. So now we know that all of these triangles are actually equilateral triangles. Therefore, that is 7, that is 7, and that is 7. So now we know we have an equilateral triangle that is 7 by 7 by 7. So how can we find the area of this triangle? Well, we would, just like we've done in the previous chapters, use our Pythagorean theorem using half of the triangle. That makes this base 3.5. Of the right triangle, the hypotenuse 7, we don't know the height. So my height is going to be the square root of 7 squared minus 3.5 squared. And then we can calculate that by taking the square root of 7 squared minus 3.5 squared. And I would get a height to equal 6.06 or 6.1 approximately. So now I know the area of this triangle is going to be the entire base, 7 multiplied by the height of the triangle divided by 2. And there are 6 of those identical triangles, so now I'm going to multiply by 6 to find the area of the hexagon. And I could save myself some time and just multiply it by 3. So I get 6.1 multiplied by 7 multiplied by 3. I now know the area of the hexagon is 127.3. There are different formulas you can memorize, but this is just the basic idea of the area of a hexagon. Today we're going to move into volume. Area is how many two-dimensional squares fill a surface. So if it's 1 centimeter by 1 centimeter, it's how many square centimeters cover the surface. When we move into volume, we move into 3-dimensional shapes. So we take our 2 dimensions and add another dimension, and now it's how many of these cubes fill the inside or the space of a 3-dimensional shape. So we're going to start by looking at prisms today. So here's a rectangular-based prism. My base of this prism is 5 by 2, or in other words, if I was to look at the bottom, there would be 10 square units covering the bottom. If I add a 1 unit height to all of those squares, I now have 10 cubes that create the first layer. So since I have 10 cubes creating the first layer, and I have multiple layers, and in this question I have 10 layers, I can say I have 10 layers of 10 cubes, which gives me 10 times 10, which is 100. And since there's no units, I could say cubic units, whatever those units are. So that is how to calculate the volume. It's how many cubes would fill in the space of that 3-dimensional shape. If it was a triangular-based prism, then I would first have to find out how many squares cover the bottom surface. So I would have to find the base, so here's my base, and I would have to find how many squares cover that surface. So I'd need the area of that triangle. The area of the triangle on the bottom is the same as the one on the top, so I would go 8 by 5 divided by 2. Base times height divided by 2, and I would get 20 square units. So I know there are 20 squares. Now if I, again, make it one height, unit height, I now know there are 20 cubic units in one layer. So if I find the area of the base, that's how many cubes layer up the first layer, and the height of my prism, or the length if it was laying on its side, you could either call it height or length, tells you how many of those identical triangles stacked together create your prism. So in this case there are 6 layers of 20, so in total I have 120 cubic units. Okay, and remember, the base does not necessarily have to be sitting on the ground. It's the shape that creates the prism, right? So the base here would be my triangle, and I have multiple layers of that triangle. For example, here's a hexagon-based prism. We could do all of that same work we did earlier. We could find the area of that hexagon, just like we did earlier, by finding the area of one triangle, knowing that this is an equilateral triangle, 6 by 6 by 6. We could find the height, find the area of that hexagon, and then multiply that by 17. I'll put the solution on my notes so that you can see that later. Same thing with a trapezoid. Remember how to find the area of a trapezoid? So this is the base, not what it's sitting on. The base is what creates the prism. It's the shape that is on the front and the back, or the top and the bottom, that are identical. This top is not the same rectangle as the one on the bottom. That is not the base. So remember, to find the area of a trapezoid, it's the parallel lines added together and divided by 2. 8 plus 10 divided by 2 is 9, so the average of those multiplied by the height. We don't know the height, but we do know this is a isosceles trapezoid, meaning those two sides are the same. So I can create a right triangle here, and I can create a right triangle on each end. Knowing that this is 8 and this is 8, each one of those sides is now 4. So I can find the height using my 4 hypotenuse, 1 base. So my height of my triangle is going to be 4 squared minus 1 squared. And I'm going to get 3.9 approximately. So I can now multiply that by 3.9, and I'm going to get the area of the trapezoid to be 34.9, and then 34.85, and then I'm going to multiply by the length. So 34.9 multiplied by 12 is, unless I type something wrong, which is always possible because something's looking wrong up there, but you get the idea. And since there's again no units, I could use U for units and write in cubed. Remember to put the appropriate unit in, centimeters cubed, meters cubed, etc. So are there formulas? We could create formulas, but basically the main formula you need to know for the volume of a prism, I would write it as area of base multiplied by either the length of the prism or the height of the prism, whichever way you want to call it. It's the same idea. So for example, with a rectangular based prism, I could call this length, this width, and this height. The area of the base is length times width multiplied by h. So that could be the formula for volume. Over here, my base is the triangle. To find the area of the triangle, we would go base multiplied by height divided by 2. I could write all over 2, or I could take a half of the base times the height, right? Because dividing by 2 is the same as multiplying by half. Multiply all of that by the length. So it could be half base times height times length. So you could create formulas as well, or you could just know it's area of base times length. And this works for any shape, okay? But this one's particular for rectangular based, and this one's particular for triangular based. And there's your formula. So let's go ahead and start trying some problems. So to find the volume of a rectangular base, the area of the base would be 3 by 2. Again, I don't put units into my formula. I just put them at the end, just making sure they're all the same. They have to be the same to be able to use them in the formula. Area of base multiplied by the height. So the volume is going to be 24 cubic centimeters. A little note here, 1 cubic centimeter is equivalent to 1 milliliter. So you can always convert those. 1 milliliter is the same as 1 cubic centimeter. A milliliter is like an eyedropper of water. So if you take an eyedropper of water, that's 1 milliliter. So in this shape, 24 milliliters would fit inside. Calculate the volume of a cube with edge length 5. Well, if it's a cube, they're all the same, 5 by 5 by 5 centimeters. So you can either write area of base 5 times 5 and then multiply by the height of 5, or you can write 5 cubed as a shortcut, and you would get the area to be 125 centimeters cubed, or 125 milliliters. Let's try this one. If this is a triangular based prism, we would first need to find the area of this triangle at the base. We know it's 5, but we know the hypotenuse is 10. We do not know this side to find the area, so base times height divided by 2. We need to know this length right there, which we can call x. So x is equal to the square root of the hypotenuse, the 10, squared minus 5 squared. So I'm going to get square root of bracket. 10 squared minus 5 squared gets me 8.7. And so now I can continue on. I can either use my formula, a half times base times height times length, or I can find the area of the base, which is 5 by 8.7 divided by 2, the area of the triangle multiplied by the height of the triangle, which is 8. And so I type all that in, multiplied by 5, divided by 2, multiplied by 8, and I would get the volume to be 173.2 millimeters cubed. Katie poured a bowl of cereal for breakfast. If the bowl is 5/6 full, how much cereal is in the box? Well, you can find that one of two ways. You can find the volume of the entire box first by multiplying 30 by 18 by 8 and get 4,320 cubic centimeters, and then multiply by 5/6. That's one way, so take 5/6 of the total. So you take your 4,320, you divide it by 6, and then multiply by 5. And I get it to be 3,600. Another way you could have done it is you could have said, well, if it's 5/6 full, why don't we just take 5/6 of the height? So 30 divided by 6 is 5. 5 times 5 is 25, right? So 5/6 of 30 is 25. So the volume is 5/6, the height is 5/6 of the total height. So if I go 25 times 18 times 8, I get 3,600 as well. So two different ways you could do it. If you wanted to know how much was empty space, you would just find instead of 5/6 of the total, you would find 1/6 of the total, the amount left over. If we know the volume of the cube, how could we find its surface area? Well, if you know the volume and you know it's a cube, you know that all the sides are the same. So in other words, x times x times x, or x cubed, is 64. So to solve for x, we would take the cubed root of 64 to get it to 4. 4 times 4 times 4 is 64. We now know what each edge length, each dimension, is length 4 centimeters. So now the surface area of a cube is to find the area of one of the faces. One of the faces is 4 by 4, which is 16. And there are 6 faces to a cube, and all of them are identical. So rather than finding all these different areas of faces, we can just multiply by 6 identical faces. So we take 16 times 6, and we get 96, and this time my units are centimeters squared, because it's surface area. So given the volume, you can work backwards to find the edge length and find surface area. If I gave you the surface area, you could work backwards. You would divide it by 6, then you would square root it to get the edge length, and then you could find volume by cubing it. So either way, whichever one I give you in a cube, you could work the opposite direction. What if I gave you a cube and I told you all the side lengths were doubled to form a larger cube? Could you find the number of small cubes to fit that? Most people's first thought would be 2, because you're doubling the length, so then 2 should fit in. But since it's 3 dimensions, you are doubling all dimensions. For example, if I made it a number, a 1 by 1 by 1, and I doubled everything, it would be a 2 by 2 by 2. So it would look something like this. All these dimensions would be cut in half. And by cutting it up, you could see, oh, there's actually 8 on the first layer and 8 on the second layer. Sorry, 4 on the first layer and 4 on the second layer, making 8 cubes to fit inside. So what we could do is, instead of using numbers, we could change this to x, y, and z, and then this would be 2x. It doesn't have to be a cube, it could be anything. 2y and 2z. So if I wanted to find the volume of this cube, the volume would be x times y times z. The volume of this cube would be 2x times 2y multiplied by 2z. 2 times 2 times 2 is 8. X times y times z is x, y, z. So we can see that this volume is x, y, z, and this volume is just 8 times x times y times z. Therefore, by doubling 3 dimensions, it's actually 8 times larger, or 2 to the power of 3 times larger. So you could probably make a prediction. What if we tripled each length? It would be 3 to the power of 3, or 27 times larger, etc. If we multiplied everything by n, it would be n to the power of 3 times larger. All right, so I will stop there. It looks like I have no more questions, and you guys can work on volume of prisms.